As we look ahead to the winter of 2025 to 2026, many of you are already asking the big questions. Will we need to buy extra shovels? Are the skis going to get a lot of use this year? Or will it be another mild season? We often talk about El Niño and La Niña, those famous climate patterns in the Pacific Ocean that have a huge say in our weather. They are the superstars of long-range forecasting. But what if I told you there's another major player, one that's a bit more mysterious, operating thousands of miles away in the Indian Ocean? This phenomenon has the power to send ripple effects across the entire globe, influencing everything from rainfall in Australia to, yes, the amount of snow we might see in North America. This powerful but lesser-known climate driver is called the Indian Ocean Dipole, or IOD for short. Think of it as the Indian Ocean's own version of El Niño. It involves a massive seesaw of ocean temperatures, and when it swings one way or the other, it can dramatically alter weather patterns far and wide. For a long time, forecasters focused primarily on the Pacific, but we are now beginning to understand just how crucial the Indian Ocean is to the global climate puzzle. So what exactly is this Indian Ocean dipole? Let's break it down in simple terms. The word dipole means having two poles or two opposite sides. We're talking about the Indian Ocean's two sides, the eastern side near Indonesia and Australia, and the western side near Africa. The IOD is about the difference in sea surface temperatures between those two areas: Western Indian Ocean near Africa, Eastern Indian Ocean near Indonesia, Australia. Normally there's a temperature balance between them, but sometimes that balance gets thrown off, creating a strong temperature contrast that triggers changes in the atmosphere. This isn't permanent, it's a fluctuating climate pattern. Think of it like a giant bathtub sloshing back and forth. Warmer water can pile up on one side, leaving the other side cooler than usual. That sloshing is the Indian Ocean dipole. It usually develops in the boreal summer and into fall. The Indian Ocean dipole doesn't just have one setting. It has three distinct phases, much like its Pacific cousin, El Niño. These phases are called positive, negative, and neutral, and each one has a very different impact on global weather. Positive, negative, neutral. The neutral phase is the normal state. The temperature difference between the Western and Eastern Indian Ocean is not significant. Warm water from the Pacific flows through the Indonesian archipelago, keeping the waters in the Eastern Indian Ocean relatively warm. This allows for normal weather patterns to prevail, with typical rainfall for places like Australia and East Africa, and no major global influence from the IOD. Then we have the positive phase. It often gets the most attention. In a positive IOD event, the script is flipped. Unusually strong winds blow from east to west across the ocean's surface, pushing the warm surface water toward the coast of Africa. This causes the Western Indian Ocean to become much warmer than average. At the same time, cooler water from deep in the ocean rises to the surface in the east, near Australia and Indonesia. This creates a strong temperature contrast, warm in the west, cool in the east. This setup leads to rising air and heavy rainfall over East Africa, but sinking air and drought conditions over Australia and parts of Southeast Asia. The opposite of this is the negative phase. It might seem strange that ocean temperatures so far away could affect whether you get a snow day in Chicago or a mild winter in Boston. The connection lies in how the IOD disrupts the atmosphere's general circulation. The massive shifts in rainfall and storm activity during IOD events don't stay contained over the Indian Ocean. They create large-scale waves in the atmosphere, known as teleconnections. These are essentially long-distance links in the climate system. The powerful rising and sinking air motions associated with the IOD can alter the path and strength of the subtropical jet stream and the polar jet stream, the high-altitude rivers of air that steer weather systems around the planet. During a strong positive IOD event, for example, the intense storm activity over the Western Indian Ocean and East Africa generates a huge amount of energy that gets injected high into the atmosphere. This energy can create a chain reaction. It can strengthen a feature known as the Pacific North American or PNA pattern. So, let's bring this all back home. How does the current forecast for the Indian Ocean dipole translate into a potential forecast for our winter here in North America in 2025-2026? As of late August 2025, the long-range climate models are showing a growing consensus. The forecast is for a moderate to strong positive IOD to develop through the fall and peak late in the year, right as we head into the winter season. Warmer than average waters off the coast of Africa, cooler than average waters near Australia. This is a critical piece of information for our winter outlook. Based on historical data and our understanding of teleconnections, a positive IOD often tilts the odds toward a specific type of winter pattern for North America. It tends to encourage a positive phase of the Pacific North American, or PNA pattern. Visual. Positive PNA map. Ridge over the west and trough over the east. A positive PNA means we are more likely to see a large, persistent ridge of high pressure anchored over the western part of the continent. This ridge acts like a giant atmospheric barrier, deflecting the coldest Arctic air and storm systems away from the west coast. For places like California, Oregon, Washington, while the west stays relatively warm and dry, that deflected Arctic air has to go somewhere. The positive PNA pattern typically forces the polar jet stream to take a deep dive southward over the central and eastern United States. This creates a deep trough of low pressure, which acts as a highway for cold air plunging down from Canada. Given the strong signal for a positive IOD, what specifically can we say about the winter of 2025 to 2026? The long-range models are beginning to paint a compelling, albeit early, picture. For temperatures, the forecast suggests a tale of two coasts. The western United States, from the Rocky Mountains to the Pacific, is favored to experience temperatures that are near or above average for the winter season. This doesn't rule out occasional cold snaps, but the overarching pattern suggests fewer and less intense Arctic intrusions. Seattle, Denver, Los Angeles. In contrast, the eastern half of the country, especially the Midwest and Northeast, is leaning toward a colder than average winter. When it comes to snow, the forecast follows the temperature pattern. The storm track, guided by that deep trough in the east, is likely to be very active. This could mean above average snowfall for a huge swath of the country. The Great Lakes region could see enhanced lake effect snow as cold air masses repeatedly pass over the relatively warmer lake waters. The major cities of the I-95 corridor could be in the crosshairs: Boston, New York, Washington, D.C., potentially including powerful nor'easters. This is the kind of pattern that could produce blockbuster snow events, the ones that make headlines and shut down cities for days. To put the potential winter of 2025 to 2026 into perspective, it's helpful to look back at past winters with similar climate setups. One of the strongest positive IOD events occurred in the winter of 2019 to 2020. That season is a useful, though imperfect, comparison. During that winter, we saw expected effects, but other factors were at play. Australia experienced devastating bushfires. The fires were fueled by record heat. In North America, the pattern was more complex, but the IOD's influence was detectable. A better analog might be the winter of 1997 to 1998. That year had a strong positive IOD. It also featured one of the most powerful El Niño events in history. The combination was explosive. El Niño dominated, producing a very wet, stormy season across the southern U.S. The positive IOD likely boosted that intensity. That winter is famous for the Great Ice Storm in Quebec and severe ice impacts across parts of New England. When multiple climate drivers align, results can be extreme. This kind of long-range forecast isn't just an academic exercise. It has real-world consequences that can affect your daily life and your wallet. If the forecast for a cold and snowy winter in the eastern U.S. proves accurate, the impacts will be widespread. For starters, think about your morning commute. More frequent snow and ice storms mean school closures, business delays, treacherous driving conditions. City and state transportation departments would need to budget for increased salt supplies, overtime for plow drivers. A single major blizzard can shut down airports for days, causing a cascade of travel headaches across the entire country. Energy consumption is another major area of impact. A persistently cold winter in the densely populated eastern half of the country would lead to a significant increase in demand for heating. This means higher natural gas bills, higher heating oil bills for millions of households. On a larger scale, it could strain power grids, especially during extreme cold snaps. In summary, the story of the upcoming winter of 2025 to 2026 is being written in large part thousands of miles away in the tropical waters of the Indian Ocean. The Indian Ocean Dipole, a massive seesaw of ocean temperatures, is a powerful force in the global climate system. Its influence travels through atmospheric waves called teleconnections, which can alter the jet stream's path and shape winter weather across North America. Understanding the IOD gives us a tool for looking months ahead. This year's forecast points strongly toward a positive IOD. Warmer waters piling up near Africa, cooler waters emerging near Australia. Historically, that pattern loads the dice for a specific U.S. winter. a large ridge of high pressure in the west, milder, drier conditions in the west, potential concerns for water supplies, a deep trough of low pressure in the east, colder than average temperatures in the east, and an active storm track. This forecast has tangible impacts on daily travel, heating bills, agriculture, and energy. This is our best assessment as of August 27, 2025, but it's still long range.